This is a video solution for the second question in the week 2 practice questions. Question 2 presents us with this U tilde symbol N025, and we're asked to say what this means in plain English. Well, the U is a random variable. This tilde says that the random variable is distributed as. The N says distributed as the normal distribution. And then these two numbers in brackets are the parameters for the normal distribution. The 0 is the mean or expected value, and the second parameter, the 25, is the variance. And just as was mentioned in class, we're always going to use the variance here when specifying a normal distribution. If we wanted to find the standard deviation, we would take the square root of this number. So, just to summarise, what this says is that U is normally distributed with a mean of 0 and a variance of 25. Part B asks us to state the values of some moments of the distribution. The first thing is the expected value. Well, the expected value is just the mean, and that is in this case one of the parameters of the distribution. It's 0. The second thing we're asked for is the standard deviation. So that is sometimes given this symbol. It's equal to the square root of the variance. And we know that the variance, one of the parameters, is 25. So that tells us that the standard deviation is 5. The next thing we're asked for is the skewness of this random variable. And skewness is a measure of the symmetry or lack thereof of a distribution. The normal distribution is symmetrical, and any distribution which is symmetrical has a skewness of 0, implying that there is no skew either to the left or the right. And then the last part of B is to state the kurtosis. The kurtosis, remember, is a slightly complicated measure, but it is affected by the peakedness of the distribution, the thinness of its tails, and the shape of its shoulders. We, in this course, just need to know as a fact that the normal distribution has a kurtosis of 3. And sometimes you might, when you hear the word kurtosis, you should just be a little bit careful as to what the interpretation is. Kurtosis is 3. The excess kurtosis, had we been asked that for this normal distribution, would be equal to 0. Excess kurtosis is found by taking the kurtosis and subtracting 3 from it. This gives 0 as the excess kurtosis for 0, which is a benchmark against which many other distributions are actually measured. And finally, part C says, what linear transformation should we apply to the random variable U so that the resulting variable follows the standard normal distribution? Well, the standard normal distribution is often given the symbol Z, and it is distributed as the normal distribution with a mean of 0 and a variance of 1. And if we start with a normally distributed variable, we can get a variable, we can transform it to another variable that follows this standard normal distribution simply by getting a z-score for each score in the original distribution, whereby we take the value of the random variable, subtract away the mean of that random variable, and then divide by its standard deviation. So in this case, that would mean that we would take each individual score in our original distribution, subtract the mean, which happens to be 0, we know from above, and divide it by the standard deviation, which we also know from part B is 5. And this will simplify that down to be ultimately that we just want to take the value of the random variable u and divide it by 5, and when we look at the distribution of that particular variable, it will be distributed as the normal distribution with a mean of 0 and a standard deviation of 1 and a variance of 1, it turns out as well. It's a linear transformation because we're simply taking the original variable and multiplying it by 1/5. Okay, that's question 2.